Okay, so we're working on electron configurations for chapter 4, and so if we want to review this, we can look at the element nitrogen. You'll notice that if you're looking at your periodic table, that nitrogen is located in your second period, and as you look across, it is located in the P block of your periodic table. So there's several different types of notations that you can do for this. The first one that we are going to look at is the electron configuration notation. So let me move the periodic table out of the way. And so we have nitrogen. Okay. Now nitrogen has 7 electrons. Some other information that's going to be valuable to know is that it's located again in the second period and in the P block. So that information right there tells us exactly where we're going and how many electrons we should have. So you need to keep in mind how many electrons your S and your P level orbitals can hold. So you always start off with your foundation. Foundation is the 1s energy level and orbital. And so we need to, actually we're going to be doing orbital notation first. We're going to reflect how many electrons. So we're going to have 1 electron going up and 1 going down. This right here, by starting on the 1s level, is representing the alpha principle. By having the electrons go up and 1 down is the Pauli exclusion principle, showing that you have to have different quantum numbers. So up and down represent positive half and negative half, which are your spin quantum numbers. So once the 1s level is full, you go to the 2s level. And so again, S holds 2 electrons. It reflects it like this. So 2s is full. Now we're trying to get to the P level, and it's the 2p. So next is your 2p. A P orbital can hold a maximum of 6 electrons. So you have to represent it with 3 lines because 1 line is a subshell and it holds 2 electrons. Now with P, you can show the different orientations or the planes that these orbitals will go through, the X, Y, and Z. The second thing I like to do is I like to put a bracket around it and then write down 2p underneath this to help me remember these all have the same amount of energy. So we've already accomplished alpha by going 1s, then 2s. Now, and we've also looked at Pauli exclusion. Now we're going to add in one more rule. It's called Hund's rule. Hund's rule states that in a orbital of the same energy level, the electrons have to be dispersed out, where each one receives 1 electron before they can go back and receive their second electron in the opposite direction for the Pauli exclusion. So for this reason, this is why I always refer to Hund's rule as being and Pauli exclusion like playing blackjack. Now right here I've actually represented 10 electrons, which would be neon. So what do we do whenever you only have 7 electrons? So look at the correct way we should do the 2p. So we'll redraw the X, Y, and Z. Okay. So we have 2, 4 electrons. Now you have 5, 6, 7. So this is how nitrogen should look right here, where it has the electrons in the 1s, the 2s, and in the 2p level.